Hi guys. Okay, today we are looking at how to find the volume of composite figures. So really what we're looking at in a composite figure is more than one shape put together. So right now we have a hemisphere, and the important thing to understand with a hemisphere is that a hemisphere is half of a sphere. So when we're taking the volume of a hemisphere, we're going to look at using the volume of a sphere is 4/3, and if we take half of that, we do 1/2 times 4/3 times pi times the radius cubed. All right, and in this case, we also have a cylinder, and so we're looking at the volume of the cylinder, and we're going to add those two together. We're looking at these two together. So the volume of a cylinder then is going to be pi times the radius squared times the height. So in this case we have a diameter and we have a height. Well, the diameter doesn't tell us anything that we need to know, but we do need to know the radius. And we know that the radius is equal to half of the diameter. So we can take half of the diameter, half of 4.5 is going to be 2.25. So in place of all the r's, we're going to use 2.25. So here we'd use 2.25 to the third power, and here we'd use 2.25 to the second power. We know that we have a height of 2.5, so over here in place of h, I'm going to use 2.5, and then I've got to multiply by pi, bring down my adding sign, multiply by pi. Here I know 1 times 4 is 4, and 2 times 3 is 6, so we're going to make that 4/6. So my volume is going to be all of this stuff multiplied. So what we need to do is figure out what is our 2.25 to the third power and 2.25 to the second power. So using my calculator, I've got 2.25 to the third power. So I'm going to round that one to 11.39 because this says to the nearest hundredth. So this one is going to be 11.39. And then I got to figure out this one right here, which is to the second power. So 2.25 to the second power is going to be 5.06. So this one's going to be 5.06 times 2.5 times pi times 4/6. Okay. So using that formula, I'm going to type that whole thing into my calculator and see what we get here. Hold on a sec. So it's a lot to type in here. So starting at the beginning, I did 4/6 times pi times 11.39 plus pi times 5.06 times 2.5. And I'm going to get 63.596, which is going to tell me to round up. So I'll have 63.60. So my volume is going to be approximately 63.60, and I'm measuring in inches to the third power. So the biggest thing is, what shapes are we adding together in order to find out our volume? So another composite figure. So we have this word problem here, and it says April is filling 6 identical cones. So we know we're using cones, and we've got 6 of them that are the same size. Each cone has a radius of 1.5 inches and a height of 9 inches. We want to know the total volume. So the piñata, remember, is made up of 6 cones. So we know we're going to have a volume. We're going to start with 6. And then we look at the rest of the formula. 1/3 times pi times the radius squared times the height. So this part right here is our volume of a cone. And because there's 6 of them, we're going to multiply by 6. So now we're going to substitute in our numbers here. We know we've got 6 times 1/3 times pi. Nothing changes there because those are all part of the number system. But we know our radius is 1.5, so we're going to have 1.5 squared times the height, which is 9. So we're going to type this into our calculator. 6 times 1/3 times pi times 1.5 to the second power times 9. And when we solve it, we get 127.234. So that 4 tells us that we can round that to 127.23. So the volume is going to be approximately 127.23 inches cubed. So remember, the only reason we use that 6 is because we know we had 6 identical cones for the piñata. So now this says here are the dimensions of a pill. So like if you think about what is the shape of a pill, you've got a sphere that's cut in half and put on either end of a cylinder in the middle. So really we're looking at the volume of a sphere plus the volume of the cylinder in there. All right, now it's given us the diameter right here. We need to know the radius. We've got the height of the cylinder here is 4.2, and then the diameter going all the way across this circle is 2.3. So we need to know what's half of 2.3. So the radius is going to be half of 2.3, which would be 1.15. So we have volume of the sphere, remember, is going to be 4/3 times pi times the radius cubed. So that covers this and this. We need to do the inside there, which is a cylinder. So in that case, we're going to add pi times the radius squared times the height, and that will cover this section here. So that should give us our total volume of that whole shape. So now we just need to substitute in our information here. We know we've got 4/3 times pi times, here's our radius, which is 1.15 to the third power, plus our pi times our radius again, 1.15 to the second power this time, and then times our height. Remember we said our height was over here. This was our height, 4.2. So this is what we're going to multiply out to find our volume of our pill here. So 4/3 times pi times 1.15 to the third power plus pi times 1.15 to the second power times 4.2, which was the height. So here we go. 4/4 times pi times 1.15 to the third power plus pi times 1.15 to the second power times 4.2. And we're going to get 23.82. So we'd have a volume of 23.82. We're measuring in millimeters, so this would be millimeters to the third power. Okay, now in this one, it wants us to know what is the volume of all 3 tennis balls. So it says we have a can of 3 identical tennis balls. The tennis balls are packed in there. So it looks like we have the height of 3 of them there. And it wants to know what is the total volume in cubic inches of all 3 tennis balls. So now know that these tennis balls are all 3 going to be exactly the same. And since it's the shape of a ball, we're going to need the volume of a sphere, which would be 4/3 times pi times the radius cubed. So I need to figure out what is the radius of one of these balls. So if we think about this, I have a height that if I divide by 3 is going to give me the diameter of one of them. Now we know that the radius is half of the diameter, so if we think about the radius, there are 1, 2, 3, 4, 5, 6 radiuses that make up this total height of 8.1 inches. So if we take this 8.1 inch and divide it by 6, that's going to tell us what is the radius. So 8.1 divided by 6 is going to be 1.35 inches. So the radius of each ball is 1.35 inches. And we know that we have 3 tennis balls. So not only are we going to take this volume formula right here, but once we get done, we're going to multiply everything by 3. So the only thing we need to substitute in here then is our radius that we just figured out. So we have 4/3 times pi times the 1.35 to the third power times 3, because there are 1, 2, 3 tennis balls. So we type that in. We have 4/3 times pi times 1.35 to the third power times the 3 tennis balls. So 4/3 times pi, oops, it looks like I forgot to put that multiplication sign in there, times 1.35 to the third power times the 3 tennis balls.